hopefully this comes online here shortly. Let's see. Yep. All right. All right, so our board is out of the ultrasonic, and we're just going to review it and see if we see anything unusual that catches our eye after the fact that it's been in the ultrasonic. And I already see something that's a little bit suspicious. So let's go ahead and go over this. So I just looked at this area just right where the board was, and that almost looks like a crack right there. And the reason why I say that is I can see the pad of that resistor, and I should not be able to see the pad of that resistor. So let's look at it at an angle. Whenever you're in doubt, look at something at an angle, and that will resolve that whatever doubt is in your mind. And that doesn't look bad. It looks like just for me probing there. So we're going to disregard that and move on. Here's our coil we replaced. Not the best soldering, but it's fine. There are Ocarina PMIC, and you can see that there's one little finding here. Look at this. See that? Alright, that's something we couldn't really see until our board was ultrasonically cleaned. And is that going to be a problem? I don't think so. I don't know. So let's look at this under the, let's see what this is in the board view. And this is PP3V3, G3H, SSD0, and Ocarina P-good. Okay, a power good signal can definitely cause weird issues. So I'm going to just touch that up. We're just going to use the smallest amount of flux here. And I'm just going to touch my iron to it. Definitely see that pad was fairly oxidized. But it can be restored. And that could be our whole issue. If we're missing a power good signal, that can affect the whole power up sequence. Alright, that's good. Alright, that's good to go. Let's go ahead and plug this in and let's see what happens. Okay. Let's go back over here to chat, and let's go ahead and do we even have, yeah, okay, good. So let's go ahead and plug it in. Let's see if we have anything different here. And this is after ultrasonic. I'm going to just keep my hand on the processor just in case it decides to go nuclear. Same thing, unfortunately. Our PCH is getting a little bit warm. That's normal. So, yeah, that kind of sucks. But again, it just seems really, really odd how it was working until when we cleaned this, that capacitor isn't going to do it. I feel like I'm missing something here. It's that gut instinct, and you won't know it until you've experienced it many times, but there's a feeling that you get when you know you've missed something. All right, this voltage is not steady here. Yeah, so 5. No, it just dropped. Now it's 3, now it's 4. Look at this. I want you to show you this on the meter. So again, we talked about intermittent connections here. How that coil kind of caused that voltage to kind of be unsteady. This is around the area that was corroded, and I cleaned this, okay? And this is why cleaning is not necessarily a good idea after liquid damage, okay? So I'm going to keep an eye on this line. So it'd help if I actually measured it. All right, 5. Oh, look, it just dropped. 5. Now it's steady. What if I measure right here? Or even better on this cap right over here. See, now it's steady. Now it's totally fine. But I still don't have V-core. Alright, now let's look at something here. I looked at this at an angle and it looked okay, but what I can see, it's really, really hard to tell. It looks almost like under the resistor is corroded. Like, it is really hard to tell. So I'm just going to resolder that resistor. This just feels like a board that's solvable. Jim Hook is here. This capacitor is unlikely to cause any issue of any kind. But just touch it up. It's fine. No via there, that's not going to matter. Thermal paste here. Let's get that out of here. Thermal paste, regardless if it says it's non-conductive or not, oftentimes has some aluminum in there, and you could see that how I just moved it and you could see it sparkling. The original Apple paste actually uses aluminum as a thermal filler, so it can cause issues even though it's non-conductive, technically non-conductive. Alright, let's try again. And then at this point I may swap Ocarina again because it technically worked. Maybe we could have a bad Ocarina. Maybe it's not sequencing right. I don't know. Let's see. 5 volts, 0.24, 0.4, 20, 0.4, 0.1, 0.16, 26, 12. This makes me think it's trying to start. It's acting like it's trying to start. Alright, time to look at the power sequence on this. Alright, yeah, we really need to get in the power sequence on this and figure out what's going on, because this is weird. I don't have an exact match for this power sequence, but we're going to look at, or do I? Is the 1055 close enough? 1055 should be close enough. Alright, so here's our power sequence. Let's follow this down. So we know we have all of this. We have this stuff. We have this stuff. We have to. We don't have this. We don't have this. VCC what? What's this actually called? PPVCCIN auxiliary PCH prim. Do we have this on this diagram here? It's probably called something else, like right here. I'm guessing one of these. So I want to go ahead and check PP1V8S3, PP1V1S3, all of those here. Let's see which ones of these are present. So let's do V8S3. All right, and that powers the memory, and that's needed before we get further in the power sequence. We have a diode here, and we're just going to check out the memory. Because for all we know, we're troubleshooting something. For all we know, we're troubleshooting something totally different. All right, maybe there's something else missing further up the line. I'm going to get my chat back over here so I can see what you guys are saying. Okay. At this point, we've ruled out a T2. We've ruled out corrosion under something. It still could be a dead CPU. Unlikely, but it still could be a dead CPU. Alright, I have 1.8 volts on PP1V8S3, so it's not that. Next one that I want to check. Let's see here. Let's see what all-sys power good is for the heck of it. All-sys power good. It's going to be missing, but that won't really tell us much other than something is wrong. That's all all-sys power good tells us, is something is wrong. But it's still worth checking. And it looks like I have a probe point on the other side of the board. It's worthy of checking. And it's going to be somewhere right here. Okay, and you are going to be directly below U5000, which is the secure element. All right, right here. It's the first one. It's right here. All right, I have 1.4 volts on all-sys power good. That tells me that's not supposed to be 1.4 volts. Let's look at this. That's making me think it's being pulled down by something. So U1912 is our next step, which is over here. Let's see. U1912 is... Go back to display capture so you guys know what I'm talking about. So what I did is I traced this back. I'm just looking for stuff that's on this rail. And this spikes my interest for sure, because this guy enables our CPU vCore, and that's what I'm missing here. So I just searched for this. Let's look. Yeah, okay. VCC, VCCIN, VREN, and VCCST power good generation, which is very important. So I want to look, okay, if we don't have our output here, we're not going to have either. So wait a second. Did I put, all right, yeah, I did. So I want to check my inputs to this. So also power good is present, PM sleep S3L, that's not going to matter. We're going to check this CPU VR ENB. And tell me that's somewhere I can measure, and it is not. Yeah, it is over here. Where are you? You're on a probe point directly adjacent to CC7A4. So CC7A4. Where is CC7A4? Looks like right here. Yep. Okay. That is 1.3 volts. So that's present. We have A and B. Do we have source power VCC? This should be working, but it's not. There we go. Okay, we have a missing rail. This is important. PP1V5 SO CPU VCCST, which is created by what? What creates this? What creates this rail? This is important. What looks like it might be a MOSFET or something. This looks interesting. Yep, alright, so VIN on pin, which is this. We have a little interesting circuit here. Alright, we need to check our enable here, which is right here. Is it being told to turn on? And this is right over here. Got it. This is really down the rabbit hole as far as diagnostic cases. Oh, look at that. There's a little chip in it. Imagine that. Imagine that. Imagine that. We might actually get this. We might actually get a working board out of this. Let's see. Is our enable here? There's a little chip in it. Imagine that. That's interesting. Alright, our enable is there. Our enable is there. VIN is there. Is our on signal there? Oh wait, our enable is there. What about our VIN? Where's our VIN gonna be? Right here. So this probably got chipped or had a chip in it or something, and then us moving around the board. Alright, it's a little bit low. It's 1 volt, but it's somewhat there. And our output is going to be missing. Our output is not going to be here. Already checked that. It's not here. Oh, and this little guy feels like he's getting hot too. Or it's just our CPU. I can't tell. Where's our output? There's a row of resistors. Follow this up. We have 3 series. It's this one. Very low voltage on output. And will my rails normalize if I take this off? Yeah, that's a pretty good fracture in the chip. That's a really good fracture. And don't automatically assume this happened because of physical damage. This can happen if the chip gets too hot. We talked about silicon last night. What happens when silicon gets really hot really fast. So, it's just a little switch. Man, this would be the best diagnostic case I've had in a long time if this ends up being true. Because the thing about this, it was so many things combined into one issue. We had intermittent ocarina, we had a crack in a coil, maybe a bad switch. So what I'm going to check now, I want to check my VIN voltage to see if my VIN voltage is now normal. And then I'm going to replace this. Okay, let it cool for a second. But man, that's a tough one. Okay. So it should be cool now. I'm going to plug it back in. I want to check my VIN voltage. I'm not expecting, we don't want our board's not going to turn on or anything because we just have our, if my VIN voltage is back up to normal levels, which should be 1.5 volts, then I think this is solved. It's nothing. Wait. Something is way too hot over here. I think it's just our board is just heat soaked. Let's let it cool. And you know what? I'm just going to replace this. So it's a TPS 22924B. Man, what a troll if this ends up being true. Let's grab a donor. Let's find a compatible switch. Should be a fair amount of them on here. Let's see here. 250 TPS 22924B. And this is going to be a hunt. It's not, why would it be easy? Of course, it's going to be some chip that is not on any other donor board and we're going to have to order it on Mauser or something. It's okay. I could literally just jump this and it would probably work. Alright, now that it's cool, let me check my inputs here. Okay. Check our inputs and enables. And also I want to check Allsys Power Grid and see if the voltage went up on it as well to normal levels. Still slightly low. Something is getting hot over here. What is getting hot? I feel it. Nothing, surprisingly. I guess I'm just losing my... Our CPU is definitely getting hot. Probably shouldn't be running it with this chip off of it, but... Alright, continuing. I gotta find this. Two two nine. Is this just the same model switch on a 1466? It can't be. They wouldn't make it that easy. 4924 is the same one, so... No way. It's the same chip on a 1466. Awesome. Okay. Thank you, Apple. Thank you for reusing a chip for once, instead of having a new custom one designed every single year. Thank you very much for using a chip that's been in use for almost 10 years now. I'm greatly appreciative of that. And I'm not being sarcastic. I'm greatly appreciative that they reused the chip. Okay, so these boards have so many of these little guys here. They're literally everywhere. So we're just gonna pull one here. This one looks cleaner. U8550, and he is the same one. Cool. And that dot is our orientation, and on our other board here, just reversed. Got it. Okay, now we're not, I preserved the balls on our board, so we should be able to just drop this down. Get down there, come on, you could do it. Just want to check the bottom for any bridges. We're good. It's aligned. Welcome to my life. Let's grab another one. Let this cool down. I'm going to attach I'm not going to attach our heatsink. I'm just going to put our heatsink on. While that's cooling down, I'll be right back. I want to check something. Nice. All right. Just checking on a MacBook Air that is in testing with carbon black, and it is idling at a nice chilly 33 degrees Celsius. That is after cooling down after a non-stop 25-hour test with Prime 95. So we're going to start our first benchmark that we're running. 33 Celsius on a machine that basically doesn't have active cooling is not bad. Okay, here we go. Moment of truth. Moment of truth. Please work. Please work, little board. At least I know kind of where to troubleshoot now. I think there might be another issue, but let's see. Come on, work. 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 There we go. That is working. That is booting current. No frickin' way. Do we have vCore back? Do we have vCore back? This is for sure booting current. vCore is back. vCore is back. That's normal for it to go up that much. It should have just posted. vCore is back at 1.8 volts. No frickin' way. That was the issue. Let's see if this gives us an Apple logo. No frickin' way. I'm happy. This was the best diagnostic case I've had in a long time. Probably almost a year I haven't had something like this that just was this in-depth, and I enjoy cases like this. And I knew that this was something. I knew I was missing something. I knew it was something solvable. It's just that feeling that you get when something is solvable. And this customer will probably be happy because he called today and was wondering why it's taken over a week so far for his laptop. And the answer is it was a very tough case. Hope it works. And the sad thing is you'll often get cases like this that you'll put back in the enclosure and they don't post, or they random crash, or they have no image or no SSD detection. That's gonna suck if that's the case. But there we go. We don't need a battery connected. I just want trackpad and screen. And if it gives me an Apple logo, then this is all good to go. And that was a fun fault to find. That was just a really in-depth. Yeah, that was fun. That was really fun. Okay. I'm not going to get fan spin anyway on this board, so it's not going to matter. 12, come on. 27. 76. It's going to go high again before posting. 82. 72. Okay, anytime now we should get some sign of life from it. Come on, little MacBook. Come on, I know you can do it. Sometimes they can act a little funny when they're nothing plugged in. 90. I don't have my keyboard plugged in. I can't tell if there's a backlight or not. The amp draw is nice and high where I would expect it for a board to be working, and it is moving around. What is my vCore at now? 6.3. There we go. Long post because there's a lot of stuff unplugged from it. There's some flux in the CPU area, which isn't a good thing. It's seeing the SSD at this point. We don't know that yet. Let's just let it sit. See what it does. Sometimes these new boards don't pass the Apple logo without everything plugged in. So I'm just going to give it a minute. The M1s do, but this one doesn't. This one might not. It's basically working. So, yeah, so it's not going to want to boot unless everything is plugged into it. Or at least most things. So I'm going to plug in the keyboard. Let's plug in a fan or two. And let's plug in the battery, and I bet this is going to boot. And if so, that's amazing. I just need to clean the flux up that we did, and we're done. But this was a fun case. I enjoyed this. And it's one that it's like, I was thinking like, you know what, this is a dead CPU. The CPU must have gotten a spike from the CPU MOSFET that was corroded, because that's usually what happens when that MOSFET gets corroded, but maybe we got lucky. Here's my battery screw. Yeah, this reminds me, I had a case in 2019 where it was this, I forget what it was, but it was on something on PM Sleep S0L. It was a buffer on PM Sleep S0L that caused a similar weird issue like this. There's that. And we should boot like this now, I would imagine. Let's see. Long post, remember, it might do that. Might help if I put a little pressure on. There we go. See, it did not take a long time to post that time because the battery's connected. There we go. Booted right up, no problem. So that's that. This one's fixed. I'm happy about this. Let's just clean our flux and then we're done. And our fan just started spinning. Yeah, the battery's good. 60% of the time I get shocked every time. What do you mean? Alright, so is Caleb here? I better just leave notes instead of expecting him to remember. Chris Long is here. Always document notes. I'm going to pull this board now. We just need to clean our flux. And then this is going to go in Caleb's queue to reassemble tomorrow. And then the customer is going to get his stuff back. And the customer, I presume, is going to be really happy about this. Because from what the customer said now, I always take these things with a grain of salt because everyone likes to lie about what happens, and it doesn't make my job any easier when people lie. But I can't tell if I hear my phone ringing or not. No. All right, so I said, is there any liquid damage? He says, no, there's no liquid damage. It's never been liquid damage. And I open it up, and there's corrosion. And he's like, oh, okay. I'm like, did you have a friend that you gave it to? He's like, oh, yeah, my friend had it. I'm like, okay, blame him for it. And the thing is in some cases you will see that someone will lend their laptop out and the friend comes back and says, hey, it doesn't work, and they were drinking or whatever and spill liquid all over it. But a lot of times people just lie about it, and I don't understand why. It doesn't. If you've ever lied about liquid damage, let me know why, because it doesn't make sense. It's not going to be cheaper. I don't care. I'm not Apple. But I don't know. All right, let's clean this carbon black off. I just grabbed it just to put a little paste on it, but it's not appropriate by any means for this application. So we're going to clean it off. We're going to apply fresh. And actually, I better use a paper towel for this. Let's see. Everybody lies about stuff like that. Everybody lies about everything. Okay, for example, if you plug a lousy Thunderbolt device into your computer and then it stops working, tell me that instead of just saying, "Oh, nothing happened. I don't know what happened." Because the thing is if I know that you plug something lousy in the Thunderbolt circuit, I know where to look. If you tell me nothing happened, I don't know where to look. So, and then do I have a report on this one for the imaging? I don't know. 6029, 6029, do I? Yes. What was this one? Alright, that was corrosion. There's no internal short. Phew, got it. 12. Okay. Caleb, Lenovo board starting with LA is Compal. It's just a random Compal board that you may find in many other machines. Boards that are made by LCFC, which is technically Lenovo, start with NM. So if it has an NM, that is Lenovo / LCFC. If it starts with LA, it's just some random Compal board that you may find in an HP or Dell or something else. So it's the ones that are LA are a little bit less quality, I find. I still can't get over this. This was a nice case to solve. And that's what we're doing today. We're solving rabbit hole cases. Thermal paste. And then there's a few things that I also want to check. Asked the lady the other day when she said her contacts just went missing on her iPhone. I said, "Did you remove any accounts?" No, no, no. Turns out she removed a Gmail account from the phone. Yep, that's how it goes. Let's clean Flux first. We gotta clean our Flux. That hurt my ear. That was a loud noise. There's another board that we just know fixed yesterday that the customer hasn't been told about yet that had a very similar issue, and I'm very tempted to take a look at that one now. This is a no clean flux. We don't technically have to do it, but I like to do it. I like to make sure the board is nice and clean after I work on it. This is good. Over here we have a little bit of flux to clean as well. At the very edge. That's clean. Good to go. Now we'll mount our heatsink. So yeah, how that little guy got cracked, I don't know. Maybe it got cracked when we took off our heatsink. It's hard to say. Crazy. I mean, it's kind of in the right spot to be cracked if we took off the heatsink wrong or just, bumped it. Which can happen because I remember saying it was fine until we did something. Or there was a pre-existing crack there. We don't know. It's a mystery. But what matters is we found the problem. It's solved. End of story. And there's one thing I want to check in the enclosure and one thing I want to check on the board still. Just the USB-C ports, that's all. So this area was corroded. These guys look alright now. Those should be just fine. And then this is fine. This is fine. Okay. Just want to check something in the enclosure real quick. Jim says, as a specialist, as expected, heart issues due to lack of meds got supply and things should now stabilize. Good. I'm glad. Good on you for getting checked out, for sure. It's not something you really want to ignore. Alright. Oh, please, no. Oh, I don't want to have to run a wire on a flex. I will if I have to, but please just be superficial. Yes, it's just superficial corrosion. Or is it? No, it's not. It's never superficial corrosion, is it? Whatever. We'll do what we have to do. What about this one? Do I at least get lucky on this one? Oh, lovely. This one too. What even is this for? Oh, and our touch bar controller is corroded. Why? We did so good. Now we're greeted with this. Really? Okay, let's work on the enclosure now. Thank you, Peter. I appreciate it. So let's take out the little touch bar module. We may have to address corrosion on that. We may not. pull this out real fast. Of course, there's corrosion under there. Pretty bad too, actually. This definitely complicates things, but we're going to fix it. I'm going to show you how we're going to fix it. We are going to make sure there's nothing that's going to get damaged in our enclosure when we set it down like this. Make sure our Touch ID is tucked down, Wi-Fi is tucked down, and we are going to set our flex just like this. Okay. Just like that. We're not going to melt anything. Okay, we're going to keep our temperature low. We're going to take that shield off. Okay. The temperature of the melting point of our connectors here is 265, so we're going to want to stay below that. And I'm going to see, yeah, I can't do anything there, so I'm just going to have to be careful here. I'm going to kind of fold this guy over. And I'm going to apply flux, a lot of flux and heat, and we're just going to pull this little shield off, and we're going to have a look underneath. The solder melts at 217. We don't really need to go much above that. So 217, let's go 245. That's plenty of margin. That's not going to damage the flex. And I'm blowing air away from my screen, although this temperature is not going to melt anything. Come on. I don't want to make a mess. There we go. There we go. Come on. Come off. Glad I took that off. That's a mess under there. It's a fixable mess, but it's a mess. This is our touch bar video controller. Most of it seems like it's going to be fine after a little cleaning. Caleb quote for new CPU, and that's it. Which is $499 B2B plus cost of CPU. It's cool enough now. If I left that, there would have been problems. Pretty clean actually now. Most of this is all just superficial corrosion, which is fine after cleaning. Switch to our micro tip and let's get to work on this. Getting there. Already looking better, for sure already looking better. That's good. Everything looks pretty good now. This one last chip needs a little bit of TLC here. Get into it at an angle. And lastly, I want to clear the solder out of these shield holes. If they go all the way through, I can't tell if they do or not. Let's see. Do they? Yeah, so I want to clear. I want to put our shield back on now. So I'm going to clean this off. I think this turned out pretty good actually. It looks pretty clean. can't really ultrasonic something like this, but I at least can clean it with Q-tip and alcohol, or Q-tip and acetone. You know what? I'm not going to bother putting this shield back on. It really doesn't matter too much. And I really don't want to expose this flex here to any more heat than I really have to, because I could already tell it's kind of stressed from the heat. So I don't want to put the shield back on and have the PCB delaminate. So yeah, we're just going to clean this up, keep it clean, and that's it. Okay, that's done. Next problem in the enclosure, let's get this reassembled, this little piece reassembled, and I do want to check touch bar too. So now touch bar you can't really check unless you provide the password, so we'll see if it'll come up on boot. If not, we'll have to call him tomorrow and get his password. But for the most part, I think it's going to be okay. So this goes down like this. You know what? Does something sit on top of this? No. There's a little shield here that we got to sit under it. This sticks down right around, somewhere around here. Yeah, the shield, so shielding is mainly for EMI resistance, and not to dispute its importance, but in a lot of cases, it's really not that important. Like, there's some applications that are really, really, really EMI sensitive, and laptops are not one of those. So it's all versus a risk versus benefit thing. All right, if I put the shield back on, I risk ruining the touch bar. If I leave the shield off, I risk some strong solar flare or something causing an issue that may never happen. So I have this stuck down onto our little thing, our little shield, and I'm just going to put a piece of Captain tape over our shield here. Clean up this flux. This is our finished result. It looks pretty good. Looks better than before, that's for sure. It's just, I'm going to clean it with isopropanol now, because there's still some flux residue that I... Everything here looks fairly electrically sound. A little bit of alcohol here. I'm going to put a piece of Tessa on that just to help out. I kid you not, it's in the Lenovo service manual for the T15, or probably a lot of machines, that intermittent issues can be caused by cosmic rays. And they're not wrong. Like, yeah, you weird, like, kernel panics or whatever. That's why it bothered. So I need to do it. I've been meaning to do a dedicated video on this. And the topic is, a repair does not make your laptop invincible. Because some people, when anything happens after a repair, it must have been something you did. It doesn't matter how long it is after the fact, it's always blamed on you. or even outside the warranty period, people get mad when stuff fails. It's like a repair doesn't make your laptop invincible for failing ever. You know, it's not a repair is a repair. It's not a, you know, pay money and your laptop is invincible for the eternity of time. It's like going to the doctor for a cold and then complaining in 20 years when you have a heart attack that it's something the doctor did when you went in for a cold. Okay, there's that. Let's finish up with a little piece of Captain tape over it. My brain is affected by cosmic rays too, Chris. Probably why I haven't been sleeping well. A little bit of Captain tape is just going to protect this from short circuiting on any kind of ground. Okay, just like that. It's over it. And I'm going to trim it. And there's that. That's done. And this goes like this. No, this. Oh, is this torn? What is this? No. So how does this plug in? I got confused here. Okay. So let's look at our board. So both of these kind of need to go the same way. I don't want to rip it. Could definitely see it had a crease here prior. I don't know, we'll figure it out. Let's continue on the other defects in the enclosure. So most notably this guy right here. So let's handle him. He's going to be easy, really easy. And we could see that we have separation of two of those lines. I'm going to try and put a solder bridge across it. If I can't, then I'm going to run a little wire. So flux of choice for this is VS213A, which is very good for stuff like this. So I'm going to put a good healthy amount on there. My smallest tip possible for this application. I set it 640 degrees Fahrenheit. So this one is fine. I don't need a wire on this one. More flux. Wrong flux, oh well. Just as good. And we're gonna get some small wire. Surprised the Pentium 3 is still working after non-stop operation. Actually, no, I don't, because stuff built back then is bulletproof. I remember someone telling me, CPUs never die in laptops or whatever. I'm like, I wish. Oh, come on, little wire. That's good. Keep getting emails. Let me just check who is emailing me. Anything important that requires my immediate attention? No, it's not, so we can wait till later. Where's that? Good connection. Good connection there. Looks good. Just want to put a little blob on this one. Beautiful. There, that is done. Let's clean it. What is that chip on your thumbnail? Probably a CPU from when I did a CPU swap live. Or video, I don't know. But that's a CPU. I have an A1398 I did a CPU swap on, and it's still working really good. We could remove the tape now. And move on to our next one. And next one is this guy right here. This one needs 3 wires. Lovely. And I could already tell this one's gonna not be a fun one. Let's go. This is our keyboard backlight. That's why it burned like that. Two wires, because one is an NC. See that? Two are an NC. So, two wires. Or, can I make this easy and just do one wire? What do you guys think? I say we're going to make it easier on ourselves. I'm going to do a loop. Nice strong point there, strong point there. Just like that. Perfect. Now I don't want to melt our fan, although we already kind of did melt our fan a little bit. So I'm going to put something there to prevent that from happening further. But let's figure this out. So let's clean this up again. Let's clean our fan up again. No, I actually did not melt this, but I need a surface to solder to. I'm going to put a little piece of Captain tape there. That's going to shield our fan a bit. Otherwise, it's kind of unavoidable. Let's clean this up. Give me 1 second. I have a phone call. I had a personal phone call, and then somebody keeps repeatedly spamming the store from an anonymous number. So we're not going to deal with that. All right, so we're going to do a little loop of a wire there. No, someone complains, I just hang up. So it's not a complaining person. It's somebody that keeps calling on an anonymous number. Nobody's on the other line. It's a troll. Okay. Clean this up. Here's the thing. If you're calling a business and you know you have connections issues, don't call from an anonymous number. Like, don't call for it. We can't call you back. And an anonymous number is just... And here's another thing. If you're having connection issues and you know that can't hear you in the other line, don't just repeatedly call time after time after time after time after time again. All right, so I'm going to do a loop. Reason why I say 2 wires, not 1, is current requirements. Yeah, anonymous numbers, almost every anonymous number is a scammer or a customer that is not being very polite. So in the first 3 calls was something wireless. Please wait while I connect your call. Yeah, no thanks. That's a scam. That's pretty good. Well, a regular repair shop owner should at least know that if they're having a connection issue, that don't just repeatedly scam call, like don't just hang up and call again, then hang up and then call again, then hang up and then call again, then hang up and then call again. Like I would never call someone from a anonymous number and expect them to answer. Okay, looks like we're almost done here. Clean this up. This needs some conformal coating. I use call forwarding too. Yeah, it's much more professional than anonymous. We're just gonna cure this. Oh, again, let's see. Let's see. We're gonna answer this live on camera. Anonymous, imagine that. Hi, how can I help you? Hello, how can I help you? Yeah, see? Told you. I'm not going to deal with that. I'm just not going to answer it anymore, anonymous. That is not a real customer. That is either a troll or somebody trolling because I'm streaming. Yeah, I'm no longer going to answer that. If it is somebody I know that's doing this, like Corbin or Caleb or something, I'm not really in the mood. I want to get some tickets cleared. I know I'm not muted. I did not mute on purpose. I did not mute my call 100% intentionally. Just going to leave this here, and I'm going to go check on the benchmark result real quick. Hello, Catherine. see, what are we idling at on this carbon black heat soak test? We're at around 43, 42, 41, 40. That's pretty good idle temps for a machine that has no real cooling. Alright, and this is cured. This is good to go, so let's clean our fan up, let's clean our mess, let's get this in the set in the enclosure. So we want to get everything sort of tested. And then we'll move on to our next rabbit hole. Alright, I want to pull out these USB-C ports and look at them, because it's really common that they harbor corrosion. Clean. Okay, so we talked about Cryonaut. Okay, so we talked about Cryonaut is not designed for that large of a gap, and it's not designed for longevity in that large of a gap. And I'm going to have a video about that very shortly. Cryonaut does provide better performance. By all means, Cryonaut does provide better performance. However, the pump out effect is going to be greater, and it most likely will not provide that high performance for very long on the A1932. Like you said, the paste that we're selling, that we created, is only for the machines that use that special Apple black paste. If you look on the website, it says that multiple times. Do not buy it thinking it's going to work on a regular MacBook. It's more of like a thermal pad in a tube type deal, which is like what Apple's paste is, their original paste that's on those machines. So Cryonaut does perform better. Cryonaut, the extreme one anyway. However, the Cryonaut is not designed for that large of a gap. It does not that heatsink does not touch the CPU. And that's that. All right, look at this. We went to look at our port. Sure enough, one is burned, physically burned. No good. Let's go grab a new one. Could use any one that fits on these. Let's see what I have here. PC board A1706. This one's fine. Yeah, the 1706, 1707 USB-C boards are fine for use, totally cross-compatible. We're making a comparison video, so don't worry about that. But by all means, if it's your own MacBook and you don't care about longevity of the thermal paste or the processor for that matter, because Cryonaut doesn't really cover the whole processor, and you just want that extra 10% or so performance difference, by all means, go for Cryonaut. And the new port had a little bit of crud on it, so we're going to clean that. Now, come on, this is supposed to be a new port. I can't use this. This is garbage. That is absolute garbage. We'll go grab another one, I guess. It happens. Okay. Is our board? Oh, you're talking about cryonaut. You're talking about the liquid metal stuff. Liquid metal is trash. Don't use liquid metal. Please don't use liquid metal on a MacBook. If anybody uses liquid metal on a MacBook and sends it here, it's not going to get fixed. Okay, you're going to destroy your machine. And for what? It's not. You're not going to get. You're not going to get better temps with that. People think I've explained. I need to make a dedicated video on this. 1 second. Yeah, we likely won't be able to test Touch Bar until the customer actually takes possession or we get his password. Some people are really weary and won't give their password up. Alright, so how does this cable go here? I'm not quite sure. Ah, like this. Got it. Okay. It folds over and plugs in. Again, I don't know how we're going to be able to tell. I don't know if Touch Bar is going to come online or not because it depends on what version of operating system they have and what settings they have. But sometimes Touch Bar will come online, sometimes it won't. I guess we could boot into recovery to see if Touch Bar is working. Yeah, we'll just do that. So I will say this, the Cryonaut is really not designed for high temperature applications. It even says on the website up to 80 Celsius. And there's plenty of threads online that say what happens if you use it long term, especially on something that gets really hot, is it does dry out from the pump out effect. And that's not what you want. And these MacBooks will hit 100 Celsius, and I don't really feel like Cryonaut was designed in mind for laptops. I think it's more of like a desktop type thing or an overclocking type thing, not a laptop or desktop, or not a laptop or MacBook type thing. And if buying the Cryonaut is 100% practical, if it's your own laptop, but buying 2 grams for like $30 if you're a repair shop is not practical. Period. It's just not. I'm gonna push this in. Come on, little connector, go in. There we go, you're in. Good job, little buddy. You went in. Alright, that's pretty much it. Battery. Screen. Celsius is actually very cold for a laptop. Fan spin. Apple logo. Yeah, no touch bar, but again, that does not surprise me because we need to be signed in too. Let's just do recovery. Like, don't get me wrong, the performance of Cryonaut is amazing. It outperforms any other product I've tried on the A1932s. It outperforms the Carbon Black. It outperforms everything. It is incredibly thermally conductive. But, again, long term. Alright, this is going to boot into recovery, and we're going to see if Touch Bar works. No, laptop temps usually hit 100 Celsius, especially in the case of all the new MacBooks, all the new laptops, all the new Intel 8th Gen and newer mobile chips are going to hit 100 Celsius under load. It's totally normal for them to do that, okay? For example, let's look at this ThinkPad I've been streaming on for quite a while. Okay, this has an incredibly beefy cooling system. It has multiple heat pipes, okay? And if we look, okay, 100, up to 107 Celsius. Imagine that. That is hot, okay? So that is throttling there. And let's see, package ring critical temperature, yes, okay. The core thermal throttling, yes. Core critical temperature, yes. Core thermal throttling, yes, okay. These chips will run hot like this, okay? They will boost really high until they hit their temperature limit, and it's totally normal for them to run like this. So 107 is a bit on the hot side, but and if we look at the cooling system setup on this laptop, let me find the picture real quick. Let's see here. Here we go. All right, this is the cooling system setup on this ThinkPad right here. Okay. Even with that, it still gets that hot. It's just the running characteristics of how those chips are. That's just how they run, and there's not much you can do to get around that. All right, I'm gonna be right back and check on this one MacBook Air running tests. course. It's doing stuff in the background, which ruins everything. I want a nice idle. I can't do a benchmark and have any accuracy if it's running stuff in the background. I want to do a benchmark where it's actually idling, not running, doing stuff in the background. Screws everything up. Okay. I mean, silicon isn't going to get hurt at 100 Celsius. Think about it. If we're doing soldering stuff, are we concerned if we're hitting something at 100 Celsius? No. Still booting into recovery. Phenon is old. Oh, this is taking a long time. I think we all might be dead before this finishes. I have gigabit internet. This is a laptop from 2020. Why does it take so long to boot into internet recovery? Like, oh, it might not help that I'm actually streaming while doing this, so yeah, that might not help. Anyway, let's put this to the side and let's move on to the next one. I have to go grab another one. New CPUs can handle a lot higher than 80 Celsius. I mean, they can get astonishingly hot. So this one is going to be, yeah, this is a rabbit hole. Oh boy, another 2251. Oh, this has flux all over it. Oh boy, this has flux everywhere on it. This will be a good one. Not a good one, but you can heat a CPU at 200 Celsius without power applied to it all day, and it's going to be totally fine. 200 Celsius isn't enough to hurt silicon. The whole concern is electron migration. That whole concern is electron migration, and that's not going to happen when it's hot, or when it's cold, or when it's not when it doesn't have power running through it. Anyway, here's an 82001958 that presented with no power post liquid damage. There was corrosion on the CPU MOSFETs, and it shows symptoms of a dead CPU. Let's clean up our area. And we did some previous troubleshooting and diagnostics on this, but I want to get it done. I want to get it out of here. If I can, I want to get it out of here. Still starting into internet recovery on that one, so okay. So this is a 01958. Well, Catherine, I haven't uploaded yet. I'm going to be very shortly though. Okay, so we've already done some stuff here, and I just jumped power to the enable to see if this line would come online, and sure enough it did. So let's go ahead and take this off, and this wire off, and let's try and figure out what's actually going on with this in an effort to reach a definitive diagnosis rather than just a nonsense diagnosis. So we know this circuit works. So first off, let's check this. So this circuit is indeed working. It's 1.8 volts. Okay. So that's working. And now it's not going to be working because I removed the power that was feeding that enable line. So our circuit works. I think I removed a resistor from here. Yeah, let's see. Alright, so next one is an 82001958. No power after a liquid spill. Liquid damaged areas were taken care of with no change in symptom set. Actually, it did have a short on PP bus, so there's that. That's just a capacitor. Is there a resistor supposed to be here? No. Yes. And is there a resistor here? I don't think there is. Phone call again. Let's see if it's the same nonsense number. Nope, it is not. All the scam calls today, I swear. Alright, let's find another. Yeah, all looks well. On this board, there's nothing missing. Alright, so let's go down the list of the power rails now. Okay, so let's start at PP3v3S5. Let's start at PP3v3S5 and work our way down. So PP3v3S5. Will show up. I want to measure it in a different spot. So U2001. Which is right here. .2, but it's doing some weird cycling, like it's going between 3.28 and 3.22 rapidly, and that's raises a red flag there, but let's continue. That's online. All right, our next one is going to be pp1v8s5. Does not have 1v8s5 on this board. So let's carry, what's our next one below that? PPVCC Prim Core. And that's different. Alright, so 1v8 Prim EN is missing. And that comes from PM Sleep Sus L. PM Sleep Sus L comes from our CPU. Alright, so PM Sleep Sus L, that's going to be a fun one. Alright, so PM Sleep Sus L is cycling up and down. Anytime I think cycling up and down, I think short. And PP3v3s5 cycling most likely correlates with that. Let's go ahead and see if we could find any abnormal enhancement on thermal imaging. Let's get our thermal imager out here. Yeah. Someone is outside my store honking. Probably want someone to come out there. I'm not going out there. You could come inside if you need help. You don't just honk outside. I've had people do that a few times, surprisingly. Well, I'm not surprisingly. Why should it surprise me what people do? It's just gunk. This is too big. There we go. Okay. Nope, you don't like full screen, do you? Alright, we'll just roll like this. Who is outside right now? There's a lot of racket outside. You gotta be freaking kidding me. trolling my number, and I'm not even going to answer it anymore. This is all scams. It's literally every single time I get a call, it's a scam. What a scam. Okay, let's continue on. The last one was my personal number, which means it must be somebody watching this that has my personal number. Who has my personal number? Okay, let's continue. So we're injecting voltage. We're not we just have our power applied. We're trying to find any signs of a short. Oh, what are you? You shouldn't be getting hot. You're a keyboard backlight. Why are you getting hot? Alright, that's a potential interesting finding. PP5VG3S. Okay, that could be keyboard backlight. That's a interesting finding. And backlight PWM goes to our T2. Any heat from our... Oh boy. That characteristic spot. I already know this. Anyway, continuing on to the other side. Anything abnormal? Normal heat from our CD3215. Let's have a look. The reflection is too great. There we go. That's not a good sign at all. How quick does this come on? Is this an actual issue or is this just... PM sleep sus L being missing is definitely odd and suspicious. Did I just see smoke or is my eyes... Am I just been looking through the scope for too much today? I can't tell. Let's go on this side and do some really, really high resolution. Imaging, okay. Definitely have power flowing through here. Reflection from emissivity, not a problem. Other board is still booting into internet recovery. Lovely. Why would sus L be cycling? If there was a short on a sus line, it could cycle. And that could cause our whole issue. It could also be cycling from an issue on a within our CPU. But sus cycling, that's unusual. That's very unusual. What is sus? We're going to trace this back. We're going to figure out wherever sus goes to, and we're going to roll this out. So PM sleep sus L goes to here. What does this do? PS5. All right, this probably, I probably don't care about this. We had liquid to here. We had liquid to here. Okay. VCC, that could definitely have killed our PCH. It's entirely possible. The hotspot is on the CPU, and there's also a reflection of the lens scene. No rhythmic cycling scene here. Sus does not really go to many things. We know this is not, well, we don't know, but this is not likely to be the issue because we jump power to the enable and it worked fine. So why would sus be cycling? Sourced internally from the CPU or CPU V, whatever. Gonna remove this resistor. Then I'm gonna remove this resistor. I'm gonna see what happens. Okay. Let's do this. Diagnostic cases like this are very tiring. They really are. Alright, that one's off. And we're going to measure in a second. It's got to cool down. Same cycling behavior. Got it. It's not this chip. Previous liquid on the CPU MOSFETs, that's highly suggestive for a spike to the CPU. And there is no other resistor right here. Alright, well, given the history of severe liquid by the CPU MOSFETs with corrosion on the VCC auxiliary pin, cycling sus is overall most consistent with an issue with the CPU. Just for the heck of it, there was issue here, and I did rework this area. The original issue was shorted capacitors. This is our keyboard backlight driver. I'm just going to remove this just for the heck of it, because you never know, maybe there's some weird issue. But pads missing or no stuffed pads. And this is still going. Shut my blinds. I'm tired. I can't wait to go home and take a nap. Alright, any change? Alright, here's a clue. As soon as I plug it in, the voltage spikes up really quick, really steeply to 200 milliamps. And what might that be? I don't know. I'm going to put my finger on the CPU and just see. I don't feel anything. That might just be what the PMIC. initialization sequence. So I'm just going to check that sus is still cycling. And if so, we're done with this. Findings are most consistent with a dead CPU, and it's not worth any more of my time. Yep. Okay, we're done with this one. I'm just going to put the heatsink back on. Look at that beautiful paste. And for anyone wondering, if you do order carbon black and this happens, this is totally normal. It's just one of the larger granules of aluminum. I shouldn't say what it is, but it's just one of the larger granules of a component that kind of got ground up in there. It's totally fine. It's not aluminum. I shouldn't say it's aluminum, but it's something similar to aluminum. It's not exactly secret what's in thermal pastes, but since this is a no fix, I got to admire my beautiful spread pattern. Okay, just put it on. There's no need for this to go on, but look at that. That is so beautiful. That is such a beautiful spread pattern. Alright, let's put heatsink screws in this. And I'm going to need spares for this because I think they got misplaced. No cracked caps. This is a dead CPU. Given the history, symptoms, it's most consistent with a CPU problem. This just fell over. I do not want this spilling on the ground. Okay. No fix B1 dead CPU. Alright, that's it for tonight. I'm done. I've streamed a lot. I've streamed a lot today. So everyone have a good night. I'll see you in the next stream or video. I need to upload